All right, well, hello, good afternoon, and welcome to the first afternoon session of this PDC. But seriously, I'm incredibly honored that so many people have come such a long way. I will try very hard not to disappoint. So my name is Lev Novik, and I'm the architect on the Microsoft Sync Framework team. And not entirely coincidentally, I will talk about Microsoft Sync Framework. As you may know, we have shipped our V1 some time ago. And since then, we've been working on V2 of Sync Framework. And I will mostly talk about the differences between V1 and V2. You will get more out of this talk if you are at least somewhat familiar with V1. I will do a quick introduction to what Sync Framework is all about. But I will assume some familiarity with some of the concepts of Sync Framework. So I will talk about what Sync Framework is all about. I will talk about some of the new in-the-box endpoints that Sync Framework V2 will support compared to V1. I will talk about Provider Framework, which is a new way of writing providers for certain stores that is incredibly easy. And then I will talk about some of the new features that Sync Framework V2 has as compared to V1. And that list is long. I had to pick some. It's very painful. So I picked some features, and I will concentrate on those. And if you want to know about any of the others, please look me up at the booth or in the lounge or anywhere else. I'll be more than happy to describe those as well. OK, so before I talk about what Microsoft Sync Framework does, let's talk a little bit about why one might even care. Why would one want to sync? And since you're all in this room, you probably already decided that sync has some value. But I want to talk a little bit about the different value that sync brings to different kinds of applications. Let's start, for instance, with a service application that is accessed by a thin client. For such an app, sync allows you to build a rich client to your service, one that will utilize the client's storage and the client's capabilities in order to talk to the service. This brings value both to your customers, in that the app is probably richer, it is probably more responsive and more reliable. And it also brings value to the service operator, because supporting a rich client takes a lot less bandwidth and a lot less processing power on the service than doing all the work on the service in real time. But on the other hand, let's say you're starting out with a client application already that is running on the client and it has its own store. For such an application, Sync allows you to connect it to the service and to benefit from all the wonders that the service can bring without having to fundamentally alter your application, without having to change it to talk to the service APIs at all times, but instead it allows you to continue to operate the way it does and synchronize its data with the service. It also allows you to synchronize its data with another copy of your application, turning it effectively into a distributed app, whether through the service or in a peer-to-peer fashion between the apps directly. OK, so Sync is good, but why would one want to use a framework? It turns out Sync solutions are actually fairly difficult to build. One of the problems is that the stores that you need to synchronize are very different. Some of them are highly capable. Some of them are not capable at all. And both types present their own different difficulties, in that stores that are less capable are difficult to synchronize because they don't support very much, whereas stores that are highly capable are difficult to synchronize because you want to do justice to all of their capabilities and provide appropriate performance. Conflicts are a bane of synchronization solutions. They're difficult to detect, they're difficult to handle after they are detected, and yet everybody complains very loudly when they're not handled correctly. That leads to either bad user experiences or even, in some cases, data loss. Change enumeration is rarely supported by stores, or at least good change enumeration rarely is. And that makes a lot of sync solutions too expensive, in that data keeps being sent between stores even though it doesn't change. Sync loops is something that synchronization solutions get into, even when they don't originally intend to. Because even as people build even if people build individual links, when you put all of these links together, synchronization loops often emerge and are difficult to handle unless you've provisioned for them from the beginning. But most importantly, in Sync, as in many other domains, building an 80% correct solution is significantly easier than building a 100% correct solution. because the number of corner cases in sync is very large, to do with loss of metadata, various kinds of connection interruptions, etc. And that is what Microsoft Sync Framework set out to accomplish. We noticed that many of the problems from the previous slide can be solved in ways that are independent of the underlying store, of the underlying protocol, of the underlying data type, or even the topology in which the synchronization solution is connected. And we set out to solve these problems, or at least as many as we can, in ways that are independent of all of these different assumptions. Take care of conflict detection, take care of unreliable networks, etc. All right, so I will very quickly, just to get on, for all of us to get on the same page, I will talk about how one uses Sync Framework. And this hasn't changed since between V1 and V2, but I will talk a little bit about this just to make sure that we're all on the same page. The easiest way to use the Sync Framework is to synchronize participating stores. You take two of these stores and you sync them using the Sync Framework. The second way is to take your store and turn it into a synchronizable store. That is where Sync Runtime comes in, and that is where I will spend most of my time in this talk. Of course, Sync Framework comes with built-in support for certain endpoints. V1, we supported file systems and relational databases. In V2, we're adding support for many more endpoints, such as SQL data services, Live Mesh, ADO.NET data services, Windows 7, etc. I will not focus on these in my talk, but there are other sessions that we have at PDC that do drill down into these, and I will have references to them at the end of my presentation. All right, we also build a set of integrated tools and user experiences on top of the Sync Framework. One of them, again, that I won't talk very much about today is Sync Services for ADO.NET, which is a very powerful tool for taking relational databases offline that is built into Visual Studio 2008. Another is SyncToy, some people may be familiar with, which is an end-to-end experience on top of the Sync Framework, which allows you to synchronize folder pairs. And we're taking that experience forward with project codename Anchorage that I will talk about in a few minutes. All right, before I do that, let's talk a little bit about how synchronization with Sync Framework actually happens. Also, just to set the terminology and make sure we're all on the same page. So Sync starts with two data stores that somebody, let's call it a Sync application, wants to synchronize. It's trying to use Sync Framework for this. But Sync Framework is not by itself capable of talking to arbitrary stores. We need help. We need sync providers, which are written by people who do know how to talk to the store, to represent the capabilities of the store to the Sync Framework, so that we could talk to those stores and synchronize them. And in this slide, and everywhere else throughout the presentation, I use green to denote things that are part of the Sync Framework, and other colors for other things. So at this point, the Sync application configures the two providers, tells them which stores to talk to, grabs a hold of a sync orchestrator, which is a component of the Sync Framework, whose job it is to orchestrate the entire process, to talk to the two providers, and get them in sync. But the most important component is that of Sync Runtime, which is really the heart of the Sync Framework that allows one to write sync providers without having to solve over and over again the same hard sync problems that we have hopefully solved once and for all. Changes flow from one place to the other. All right, so if that's what the Sync Framework does, then how do developers interact with the Sync Framework? Well, it turns out, as should be apparent from the previous slide, there are two ways. One is people write sync applications that synchronize different stores using built-in providers, or using providers that other people have written, or using providers that you yourself have written. Secondly, people write providers themselves. Whenever you encounter a store that doesn't already have a provider, and you do want to sync it, you need to write a provider for it, and that is where Sync Framework's runtime helps you accomplish this task with hopefully not too much effort. All right. I will talk about one of the sync applications that we are actually shipping, which we codenamed Anchorage. And we're taking forward SyncToy v2, but Anchorage is not intended as a single domain synchronization application. It's not intended to be a photo sync tool or a contact sync tool. What it is intended to be is an ecosystem builder for your providers. It is intended to allow somebody who writes a provider to be able to plug it into this common environment and to immediately connect it with all the other providers that other people have written for the same data type. And it allows you to get your provider into the end user's hands much more quickly than if you had to build your own experience from scratch. Of course, we did seed this application with the endpoints that we already support, such as Live Framework, including Live Mesh and Live Contacts, as well as the endpoints that are built by some of our partners, such as SmugMug and Photobucket. We have partnered with Photobucket and SmugMug to enable their services to be synchronized using the Sync framework, and those will be some of the endpoints supported in Anchorage, as well as all the endpoints that we ourselves have built support for, such as file systems. Before I talk about that, though, let's look at what it takes to actually write a sync application yourself if you are so inclined, because Anchorage is certainly not the only sync application that will get written or used. Well, that's pretty much what it takes. All you need to do is instantiate Sync Orchestrator, instantiate one of the providers. In this case, it's a file sync provider that's pointed at a folder. Instantiate another provider. In this case, it's a Live Mesh provider that's pointed at a mesh folder, and synchronize them together. It is really easy. But while on the subject of Live Mesh, let me talk a little bit about the relationship between the Sync framework and the Live framework, and how the two work together. Let's start by just looking at the mesh and what it does and what mesh applications do. And I assume that most of you are familiar with Live Mesh to some degree. Mesh has the cloud components and the client components, and it has storage in both of these places, making sure that whatever data is stored in the mesh, it flows throughout from the cloud to the client, or at least to all of the places where you have configured the data to flow, whether peer-to-peer or through the cloud. And it's using FeedSync protocol to accomplish this. When you write an app to the mesh, that app can talk to the cloud operating environment, or it can talk to the client operating environment, or it can even move between talking to the client and talking to the cloud without having to change the application. Neither one of these apps actually needed to worry about synchronization. It just uses Mesh APIs to read and write the data, and Mesh takes care of making sure that your data is where you need it to be. But let's take a look at another kind of an application. Let's start with a client app that runs perhaps on the same machine, has its own app store, is coded to work with that app store, and wants to stay that way. That app will want to have its store synchronized with the mesh, and so that its data would also appear in a cloud and would also be synchronized to other mesh-enabled PCs or devices. And that is where Sync Framework comes in. Using the Live Framework provider, which will be part of Sync Framework v2, and a provider that is written against your app store using Sync Runtime, and the Sync Framework Orchestrator, you can connect the two and get the data to flow from the app store to the mesh and back. That is very easy to do. I will be showing an example of that in a little bit of time. But things get a little bit trickier with a web app. A web application also has its own app store, but this one is in the cloud. And this web app also wants to be able to synchronize its store with the mesh store in the cloud. Well, you can accomplish that in exactly the same way by getting a hold of a Live Framework provider, building a sync provider to the application in question, and synchronizing them. And the data will flow from the app to the cloud, but you can see that it's taken a somewhat circuitous path, in that it went through the client and back up to the cloud. The good news is that because the sync technology is multi-master enabled, you can run this on any number of clients. Everything is going to be correct. Nothing is going to get confused. But the path was fairly circuitous. You can make it a little bit better by pointing the Live Framework provider directly at the cloud operating environment, but the data still flowed through the client. What you really want to do is take all of this and hoist it up in the cloud and run it there in the cloud, so that the data could flow from the app store directly to the mesh without having to go through the client. And this is what we intend to do. We don't have it today, but this is where we're going. By making the sync provider effectively a mesh application that can run in the cloud, we will be able to accomplish this. So that is the relationship between the Live Framework and the Sync Framework, and you can see how the two work together to enable your scenarios. So let's say you are actually going to write a sync provider, whether because you have an app that you're trying to synchronize with a mesh, or perhaps with something else, perhaps with another store of yours, or perhaps with SQL data services, or anything like that. What are the responsibilities of a sync provider? Well, the store that you're writing a provider against has certain responsibilities. It must track changes. It must know when things have changed in the store, and it must store sync metadata. As anybody familiar with V1 will know, the sync framework defines a certain metadata, objects, versions, and knowledge, and we expect the store to be able to persist them. The job of the provider is to expose these store capabilities. The job of the provider is to say, oh, now that I understand how the store works, I can expose these capabilities to the sync framework so that it could connect this store, this store and this provider with other providers. But it turns out there are very many stores that have very little in the way of such abilities. Think of a fat file system. It has no place to store metadata on a file. It has no ability to track changes. So what does a provider to do? If there are no sync abilities in the store, then the provider has nothing to expose. And we, the sync framework, should be able to take on all of the responsibilities, all of the actual sync responsibilities for this scenario. And that is exactly what Provider Framework does. Provider Framework is a V2 component and comes in two flavors. Or rather, providers that are written to it come in two flavors: full enumeration providers and anchor-based providers. A full enumeration provider is intended for a store that is similar in its capabilities to the fat file system. And it is required to be able to do four things. First, it needs to be able to enumerate all of the objects that are in its scope of synchronization. Synchronizing files, I may have a for each loop over all the files in a folder. If I'm synchronizing contacts, perhaps I'm going to have a for each loop over all the contacts in the address book. Second thing is I need to be able to specify a set of properties of those objects that tell objects apart. For a file, for instance, its path is a pretty good way to tell one file apart from another. For a contact, perhaps it's a name, or perhaps it's some inherent ID that your store supports. As long as it doesn't change willy-nilly between sync sessions, it is a good way to identify your object to the provider framework. Next, the provider needs to find a set of properties that will tell us when the object has changed. For instance, if you're using a file, last modified time or last write time is a pretty good candidate for this. If you're using contacts, maybe you don't have anything. Maybe you don't have a property that would fulfill this role, but a hash will always do the trick. And what we find is that in every scenario, there's typically a combination of properties that can be easily used by the provider to tell when an object has changed. The only thing the provider needs to do, however, is tell us what these properties are. And finally, the provider needs to be able to create, delete, and update the individual objects. So in the case of files, for instance, you need to be able to create files, update files, and delete files. But you don't need to deal with the metadata that is associated with these objects. You only need to be able to manipulate the objects themselves, which frankly, one certainly couldn't build any provider without. All right, if you're trying to use an anchor-based provider, the anchor-based provider is intended more for stores like NTFS, which, as many of you are probably aware, maintains a journal. It is basically capable of enumerating all the changes that have happened since a certain point in the past. And that is what anchor-based providers expose. They're capable of enumerating changes since some point in the past. But the provider gets to define what that point is. We do not mandate that. The provider may choose to do it on the basis of time, or on the basis of tick counts, or on the basis of USN, as in the case of NTFS. But what you decide is your own private matter. You do not have to agree on this mechanism with the other providers with which you're synchronizing. It is between you and the provider framework. And that eases up and increases the number of stores on which anchor-based providers can be easily implemented. All right, so let's look a little bit at what provider framework actually does when it is used to implement a provider. Technically, you don't need to know this in order to use the provider framework, but I'm sure you're just as curious to find out as I'm eager to tell you. So, all right, let's start from the enumeration side. Okay, so in the enumeration side, as you may recall from V1, sync orchestrator will call the provider and say, get me a change batch. Get me a batch of changes that I need to send to the other side. Okay? Now, provider framework has a perfectly good metadata store that it is controlling. And it could answer that question. But the metadata store is not up to date because nobody has been maintaining it, certainly not the simple provider. So the first task for it is to bring it up to date. So the first thing it's going to do is going to use one of the methods from the previous slide, call the simple sync provider, and say, enumerate all your objects. Provider is going to go to the store, and then it's going to report its objects into the provider framework. So for instance, in this case, it's reporting an object with identifying properties of foo, that's maybe the path or whatever the provider has chosen, and the version identifying property of 5 p.m. Okay, that's a great object. What is the provider framework going to do? It is going to check with the metadata store to find out what did the object look like last time. And there could be 3 possible choices here. One, it may find out that the object is exactly the same as it always was. It may find out that the object has been updated since last time, because that 5 p.m. doesn't match what we had in the store. Or it can find out that the object is entirely new. There was no foo last time around. Whichever of those is true, it will correctly update the metadata store. It will issue, for those who remember the metadata model of sync framework from V1, it will issue a new update version, a new tick count. It will store the right update version in the metadata store, and will properly maintain the knowledge of this replica. All right? Meanwhile, the provider keeps reporting objects at the provider framework, and finally, it is all done. It has reported all the objects. But the framework still has one more thing to do. It needs to figure out if anything is missing. Was there anything that was reported last time that is not reported this time? If there is, it will record the appropriate tombstones in the metadata store, again, issuing the appropriate delete versions and doing the appropriate metadata management. Realize that the provider itself didn't know what got deleted, but the provider framework can figure that out. All right? At this point, the metadata is up to date, and the framework can correctly answer the question. This is a V1 feature that you may be familiar with if you looked at the metadata store interfaces, where enumerating changes using the metadata store is a fairly trivial task. All right, moving on to change application. Of course, there is absolutely no reason to believe that both sides of the synchronization session are using provider framework. One may be, the other may not. But for the purposes of the slides, I'm going to assume that both do. Another thing that I wanted to mention is the slides, of course, oversimplify what actually happens. And the sync framework, the provider framework doesn't talk to the metadata store one object at a time. It uses adaptive batching in order to make sure that the way it interacts with the metadata store is actually efficient, but that wouldn't make for a good slide. So as far as change application is concerned, sync orchestrator calls process change batch on the applying provider to say, these are the changes that you need to apply. The first thing that provider framework will do is say, my metadata is once again out of date. So we'll go through exactly the same process and get the metadata up to date on the other side as well. At this point, it will read the current versions from the metadata store and follow the same process that a provider typically does in sync framework to using the sync framework runtime to figure out which objects are in conflict, which objects have been updated, etc. And then for every object that has actually changed, it is going to call the simple sync provider and tell it to do one of those CRUD operations, create, update, or delete. So in this case, it is calling it and telling it that an item with ID foo being whatever it is that this particular provider called it, whose last modified time was 1 p.m. last time we checked in this store, has now been updated, and the values are now barred. The job of a simple sync provider is to check for race conditions, where it checks whether the last modified time in the store is still 1 p.m. If it's not, and if it is, write the object. Otherwise, complain to the provider framework, and it will take care of that by handling an appropriate conflict. When it's done, it reports the new set of those properties. Remember, the provider decided which properties it's going to use to identify versions and which properties it's going to use to identify objects. It returns a new set of these properties back to the provider framework, which updates the metadata store, and the metadata is now up which updates the metadata store and is now capable of performing change enumeration or the next change application in the next session. Okay, so let's take a look at what it actually takes, or what a full enumeration provider actually looks like. So I have written a simple file provider for this purpose, where I implemented a new file. Even though file sync provider comes with provider framework, I implemented a new one just as an example. Now, of course, file sync has been done to death, but it's still a very good example to look at synchronization problems on, because most of the synchronization problems occur. Okay, so I'm going to look through. I'm going to walk through all the sync-related code of the simple file provider, and then we'll see it in action. So the first thing the provider needs to do is it needs to specify those properties that it will use for identification. And this is what this code does. It declares two properties, one for path and one for last modified time. It declares an identity rule, which says any two objects whose path is the same are the same, and not otherwise. And then it constructs a schema definition and returns it back to the provider framework to say, this is what I'm going to give you whenever you ask me for things. Next thing that it needs to do is it needs to implement that enumeration method that enumerates all the objects that the provider has. And this is what this one does. It's enumerate items. And what it does is it goes through all the files in the folder. Remember, this provider was configured with a root folder that it's supposed to synchronize. And for each, it returns a dictionary that contains those two properties. In this case, two properties, could be more. The two properties that this provider has chosen to identify its objects and versions, namely the path and the last modified time. And at this point, it is done with that particular task. Okay? Now for updates, let's take a look at that. It needs to implement three methods: insert item, delete item, and update item. Let's look at them. The insert item method, the insert item method is given the object to create, and the only thing that the provider needs to do is the following. It figures out what the local path for the object is going to be by combining the root folder with whatever it was given. Then it checks whether the local path already exists, and if so, it complains to the provider framework, and we'll look at this code in more detail in the second part of the presentation. Otherwise, it copies the data in the right place, and then it returns the particulars of this newly created object back to the provider framework. The path, of course, is not terribly interesting in this particular case, but it does return the last write time so that the provider framework would know what just happened. Delete item is not much more complicated than that. It is given the properties of the item to delete, specifically the path and the last modified time, of course, because these were the properties that the provider itself reported last time back. And what it needs to do, having figured out what these properties are, is to figure out the local path and then do some checks, some race condition checks, specifically that the file hasn't been changed locally, that the last modified time is still the same as is reported by the provider framework. And if so, delete the file and be done with it. Update item is the hardest one. It has the most of the checks because it sort of combines the logic of insert and delete. And what it does is it's told, again, which object to update, so it can construct the old local path. But now it is going to figure out the new local path because it may be given a move in this particular case. And I've written this provider to support moves to illustrate that feature as well. It needs to do a couple of race condition checks. It needs to make sure that the file is still there, and it needs to make sure that the file hasn't changed since last time. If any of these have happened, it needs to complain. Otherwise, if the paths are different, it needs to move the file. And otherwise, and regardless, it needs to copy the new file whose data was given to it into the correct location, and then once again return the particulars back to the provider framework, describing its relative path and its current tick count. And that is it. Let's actually run this, and I'm going to illustrate this by actually demonstrating the codename Anchorage that I'm going to run in the debugger. And I want to thank the Effective UI company that has helped us greatly in design of this UI. And let me walk through the UI just a little bit. you can see that Anchorage is all about creating groups of replicas that you want to keep in sync. So for instance, I have already a couple of groups pre-configured here. One is called Pix, and it has 3 endpoints that are already set up to be synchronized. There's a local folder, there's a folder in SmugMug, and there's a folder in PhotoBucket. As I mentioned, we have partnered with PhotoBucket and SmugMug to enable those services for synchronization. Now what you see on the left is a list of all the providers that are willing to play in this ecosystem. And this is where you would see your provider if you were to register it with Anchorage and allow us to sync your endpoint as well. So let me add live mesh to this group. Now this is all completely live and not in any way fake. So things are, and so let me also go to this timed out. Let me go back to, I have this album already, as you've seen, this relationship pre-existed. So I have this album in SmugMug, sorry, this is PhotoBucket, and it has 3 pictures in it. I have this album in SmugMug, and that has 3 pictures in it. So let's go to PhotoBucket, and let's add a couple of pictures to it. Let's upload them to the service. The network is a little slow today, so bear with me. Okay. And now let's go back here and initiate synchronization. Now, as you can see, it'll take us. Unfortunately, the network is being a little bit slow, so it'll take a little bit of time to actually get all of these endpoints synchronized with each other. But you can see that progress is being reported, pictures are flowing between these endpoints. And the goal of this is to say, even though I've edited to only one of these endpoints, namely PhotoBucket, what I want is I want for these pictures to be found in all of the other endpoints that are configured to be synced. So hopefully in a moment it'll finish. You can see as pictures are being uploaded. We can switch to, for instance, what shall we look at? Let's look at live mesh. And we'll find that it has a new folder in it called live demo, which we just created. And in it are all 6 of the pictures that we have just synchronized. And what I can do is I can, for instance, delete a few pictures from here, sync it with the rest of the properties, and the changes will propagate. But that is not really what I wanted to show. I wanted to show a little bit of what Anchorage looks like. But now let's go back to the provider that we were trying to test. So let's create a new test sync group. It's called Simple. And once again, let's use live mesh. Oops. Because realize that provider that we just wrote can be synced with live mesh with no additional code changes. It's called Simple this time. And let's add a local folder provider. And what I'm going to do is I'm going to check this conveniently placed checkbox for using the demo provider, since I've plugged in that provider that we just saw into Anchorage so that Anchorage would use that instead of the real file sync provider in the framework. OK, let's sync. I have put a few files. I've put 3 files specifically in that directory on a local machine that I just configured. And indeed, what we're going to see is we're going to see a breakpoint hit in our enumerate items. And what we're going to do is we're going to go through each of the files in the folder. In this case, it's 0003. And we're going to report them to the provider framework. That's 1, that's 2, that's 3, and we're done. Are we going to see anything else hit? Hopefully not. And all the files are being synced to live mesh. I can go back, look at the simple folder that just got created. And the files are there. Let's do something more interesting. Let's take, for instance, this first file and delete it from the mesh. And let's go back here and delete something like this file from my folder. And let's sync again. Once again, I'm going to get a call to enumerate items. But this time, I'm only going to find 2 files, because remember, I deleted one of them. That is all my provider did. But the provider framework has figured out that something has been deleted. That, however, isn't it. This is provider framework having been informed that something got deleted in the mesh, calling me and telling me to delete my file. Oh, straightforward. Provider framework told me exactly what the relative path of my file will be, so I figure out what its full path shall be, make sure that the race conditions didn't happen, delete the file, and off I go. We'll wait a second while everything comes together. And we can look in the mesh, for instance, and oh, voila, files have been synced, and I now only have one of them left. Same is true for my simple folder. OK, great. So that's what it took to write a provider. It really wasn't very hard, as you may have seen. But now let's look. The goal of the provider framework was exactly this, is to allow people to write providers with very little work, particularly for stores that either don't have very sophisticated capabilities or, and this is important, simply don't have enough data to warrant being smart about the provider. If your store has 100 items in it, it is really not that important how efficient your provider is. The only thing that's important is that your provider be correct. And there is absolutely no functionality trade-offs that are introduced by writing a full enumeration provider. A full enumeration provider is just as good as detecting conflicts, at resolving conflicts, at handling connection drops, at handling various kinds of failures, all the way up to the loss of metadata. So, provider framework is available in Sync Framework v2 CTP1, which is either available on the web right now or will be in a couple hours. So I encourage everyone to go and play with that. I wanted to talk for just a couple seconds about writing providers. There are a couple of things that you can do in your store in order to make that store work so much better with the Sync framework. One of them is storing per item cookies. If there is a way in your store to associate a bit of information with every item whenever that item is updated or created, that greatly reduces the number of race conditions that the Sync framework has to handle. For instance, this is one of the things that both Photobucket and SmugMug did in their services, and that dramatically improves the sync experience to those sites. The other thing, of course, is to implement an anchor-based provider. If your store has an ability to implement anchor-based enumeration, that's wonderful. But it is often difficult to do so, because one of the things that an anchor-based provider needs to do is store tombstones and be able to enumerate which items got deleted since last time. If your store cannot do that, it turns out that there's something else you can do that is not as good, but still helps greatly in optimizing performance, and that is keeping item counts. If you can tell how many items are in your folder at any given time, or how many items are in your entire scope at any given time, that will allow us to skip delete detection at certain times and optimize our sync sessions. Again, those familiar with V1 metadata will recognize that because we maintain creation versions, we can tell the difference between items that have been created and updated, and that allows us, that combined with item counts, allows us to tell whether any deletes have occurred in the past or not. All right, let me switch gears and talk a little bit about some of the new capabilities that are coming in Sync Framework v2. What I've talked about so far were not strictly new capabilities, there were easier ways to accomplish the same things. So the new capabilities that I'm going to talk about are broadly divided into two categories. The first is filtering. While filtering was supported by Sync Framework in v1, we're adding support for column filtering, which is where a provider chooses to keep only a portion, only some of the columns of the item. We support filter negotiation, which allows providers to determine which filter the other provider wants to use, as well as more sophisticated concepts such as providers forgetting and remembering items. I'll talk a little bit about this later on. The second group of features have to do with conflict handling. First is constrained conflict handling, dealing with constrained conflicts where two items with the same name are created or some other invalid action is taken by one of the replicas. And the second part is conflict logging support, which again, while supported in v1, is made more sophisticated and more advanced in v2. So let me start by talking about filtering. Why filter objects altogether? Many endpoints find that while they want to participate in the sync community, they don't want to get all of the objects that are being synchronized in that community. Some of them want only emails from John, some of them only want 3 months worth of calendar appointments. Sometimes these filters are permanent, sometimes these filters are temporary. Sync Framework v1 supports filtering. This filter change batch that is part of the v1 SDK that you may be familiar with. But what v1 doesn't give you is the ability for the two providers to determine what kind of filter the other provider wants to use. And this is one of the features that we've added. We've added two interfaces: I support filtered sync and I request filtered sync, which can be implemented by the providers to indicate willingness and desire to use a filter. The orchestrator will then negotiate filter use among the providers between the providers to make sure that the desired filter is used, or else the provider that desired filtering is informed that this is impossible. Provider Framework supports filtering and supports these interfaces and makes them easier to use. Column filtering is a different kind of filtering. In this situation, an endpoint decides that it not so much doesn't want to get all of the objects, but rather it doesn't want to get the entirety of a single object. This is particularly common with devices, which simply can't represent the full richness of the data model of a PC or a service. And when they convert the data to the device format, this conversion is lossy. Some of the properties are lost. So let's look at an example of that just to make sure that we're all talking about the same thing. In this case, I have two PCs and a phone, and I'm synchronizing contacts. And the first PC has a contact for John Doe, has a phone number, and it has a spouse name. It syncs it to the phone. Now, the phone can't represent the spouse name. So it has the contact for John Doe now, minus the spouse. The phone is happy because it doesn't know anything about spouses. But when it syncs it to PC2, PC2 is now missing the spouse, even though it could have represented that. It is now unhappy, but this particular situation can't be helped. The data went through the device that simply couldn't represent the spouse. But what's interesting is what happens when the two PCs are finally connected directly or through the cloud in some way that doesn't lose the data. And what you want to happen is that this time you want to make sure that the spouse that was missing from PC2 is sent to it from PC1. And this is what column filtering is all about. So what's supported by Sync Framework v2. In order to describe how it is supported, I need to talk a little bit about a feature of v1 that is not very commonly known, is not very commonly used, and that is change units. v1 supports change units, which is an ability to specify a granularity of change tracking below the level of an object. We group properties of an object into multiple change units, allowing us to send only the change units, only the properties that have actually changed, instead of sending the entire object, as well as making sure that updates to different groupings of these properties do not result in spurious conflicts. That is something that is supported by v1, and it is now supported by Provider Framework, in that if you'd like to divide your object into a number of property groups, you can very easily do that by reporting, when you're reporting items, by reporting several item fields and specifying some kind of a version property for each. Now, of course, realize the more change units you have, the more metadata Sync Framework is going to have to keep. But this increase in metadata is very small. As you may recall, in general, Sync Framework keeps a creation version and an update version for every item. Well, of course, if you're going to have multiple change units, we're going to have to keep an update version for every change unit. The creation version stays the same. And of course, there are no extra vectors or no extra histories that need to be kept to support this feature. If your provider supports change units, then adding column filtering is pretty straightforward. You implement I support filtered sync and I request filtered sync interfaces to indicate your ability or desire to project objects onto the sets of columns, and then you enumerate the changes according to that filter. If you're using Provider Framework, then it takes care of implementing I support filtered sync as well as enumerating changes. But of course, only you know which change units you want and which change units you do not want, and so you are left implementing that. Sync Framework takes care of manipulating the metadata in a way that makes sure that exactly what was drawn on that picture will happen, and that spouse name is going to flow to the second PC without the entire contact flowing or without spurious conflicts being detected. We're introducing a new notion inside Sync Framework's knowledge. Again, for those who are familiar with the depth of the metadata, there's a notion of filtered knowledge, which allows one to represent which change units a replica has and which change units a replica doesn't have without ballooning the size of knowledge at all. So it grows very, very little. there are many things that I've oversimplified as far as description of column filtering that pain me to skip because they're so interesting and so fascinating. So I'll just mention one of them. And if anybody is interested in this at all, look me up. What should happen if you delete an object for which a replica only has part of the data? Is it a conflict, or should this be allowed? This turns out to be a rather non-trivial question to which we have some interesting answers, which don't complicate the model for provider writers, but are quite fascinating to implement. All right. Let me talk quickly about another important addition to Sync Framework v2, and that is support for constraint conflicts. Typically, when we talk about conflicts, we talk about concurrent updates. We talk about two people updating the same object on different replicas at the same time. Constraint conflicts are different. They occur when replicas do things to different objects that nonetheless cannot be allowed. One of them is, for instance, creating two files with the same name. That's a very common example. But others are simply doing things that on one replica that another replica considers to be illegal, like setting a city name that somebody enforces as not being a city. Sync Framework, of course, cannot detect these kinds of conflicts. Only the provider knows its business logic. Only the provider knows what rules exist for what's legal and what's not. But Sync Framework allows you to report, log, and resolve such conflicts, and also to rearrange the application of changes to avoid them. Sometimes, if your conflicts have to do with uniqueness of objects, rearranging the order of changes allows you to not get into the situations, and we support that quite easily in v2. Again, provider framework, of course, as usual, makes these capabilities easier to use. You don't have to use the provider framework to benefit from these capabilities, but it does make it easier. Let me talk about, in more detail, about one particular type of these conflicts. And those are the identity collisions. Example of two files being created with the same name, two contacts being created for the same user. Providers detect these conflicts, and Sync Framework supports two kinds of resolutions for these. You can keep both of these objects and modify them so that they would no longer collide, or you can merge them to produce one object from two by basically saying, hey, this is the same object, I should really only have one. Let's look at what happens to the metadata and what the provider framework, or what the Sync Framework rather, actually does to accomplish this. So in this example, we create two contacts. Both of them are for John Doe. They're created on different machines, and you can see that their IDs are different, GUID1 and GUID2. And in fact, their phone numbers are different too. When the two machines sync, let's sync from machine A to machine B first. The contact gets sent, and the provider on machine B detects a conflict. It says, I cannot have two contacts with the same name. Now, there are three ways to deal with this conflict. You can not deal with it, which is a good option sometimes. You can postpone it for later. Or you can decide to keep both, or you can decide to merge them. Let's look at keep both first. In this case, the provider says, all right, I am going to fix the name, because really these are two different guys. One of them is John Doe, the other is John A. Doe. It was just not typed correctly. Of course, Sync Framework will increase the update version to make sure to reflect this update. And at this point, the update can be applied. We're going to have two contacts, one for John Doe, one for John A. Doe, and machine B is happy. On the way back, automatically, of course, we will enumerate this change. Since the update version was changed, this object will flow to machine A, where it's going to get applied without a conflict this time, since the name has been fixed. And now machine A is happy as well. If the provider were to choose the merge resolution, things get a little more tricky. We need one object. What we're going to do is first we're going to merge the two objects as provider requested. So either, in this case, provider said, remote data that came in, that's the good data. The one I had, not so good. Second thing is updating the version, of course. The second thing we're going to do is we're going to pick one of these contacts as a victim, and we're going to delete it. So now we have a tombstone for the contact that has lost. And now we're going to apply this delete to my second replica. This machine is now happy. It has one merged contact, and it has a tombstone for the other, which the user on this machine, of course, doesn't see. When the changes flow back to the other side, both the contact and the tombstone flow, and you can see that there are no conflicts this time, because the tombstone overrides the original conflict, the contact is created, and machine A is now also happy with its single contact and a single tombstone. Now, Careful observer may have noticed that if the machines were to pick different contacts as victims, bad things would happen. Unfortunately, there's a whole bunch of details that I'm not getting into, but this won't happen. We're very careful about picking our victims and making sure that this will not occur. Again, if anybody wants to know more details about how we do it, I will be more than happy to describe it. But this is what happens. This is what happens in the sync framework, and this is what happens with the metadata. Let's look very quickly at what the provider had to do in order to actually implement this. Now, I'm going to use the exact same provider that I had. And let's take a look. And basically, the provider has to do 3 things. One of those things we have already seen. Remember, inside my insert item method, I checked over here if the file already existed. And if it did, I reported a constrained error back up to the sync framework. So that was task number 1. The second task is to be able to choose which resolution should be taken when a conflict occurs. This is done by implementing a new method on constrained conflict. This method is called by the sync framework to tell you, hey, these 2 items were declared to be identical. They were declared to be in conflict. What do you want to do? This provider chooses a silly policy for this. It basically says, if the files are of the same size, then I'm going to assume that they're probably the same, and I'm going to keep the remote one. Otherwise, if they are of different size, then I'm going to assume that they're different, and I'm going to rename one of them. OK, that's not a terribly useful policy, but certainly one could implement a smarter one, and the policy definitely depends on the particular domain. Now, if you choose the rename policy, then you need to do one more action. You need to implement one more method, which is the method that will be called to actually implement the rename, to actually figure out how to change one of the objects so that it wouldn't collide with the other. And in this case, this is what this provider chooses to do. What it basically does is it gets the old file data, the file data that collided, and it constructs a new path, where it simply takes the old path and adds a -new. Again, not the most robust piece of code, obviously. You do it twice and it won't work anymore. But this is just by way of illustration. But this is the only thing that the provider has to do. It generates the new data, and then it calls its own insert item to basically say, well, this one will go through. The other one didn't, but this one will. OK? So let's actually try to see this in action. So I have this. We have this folder here. And let's go to the mesh, and let's try to upload a file. I have this wonderful file called lake.jpg. And let's go here, and let's copy another file called lake.jpg into my folder over here. Let's sync and see what happens. Will eventually happen. The first thing that happens is, of course, my enumerate items is called. I'm not going to go through this again, because we've already seen how this method works. Then insert item is going to be called because I'm being told that I should create that picture that we just uploaded to the mesh. This time, the existence check will trigger, and the provider will complain to the provider framework, saying, I already have one of these. I can't create it. Now my own constraint conflict is called, and I'm told, what is the object? The object is lake.jpg, and I'm told, we can't create. You told us that we couldn't create this. How do you want to resolve this conflict? So what this provider does is it checks the sizes, finds that they're different, and is going to decide to keep both. Well, since that is going to happen, we're going to get a third call that says, how would you like to rename this object? And the name of the object is lake.jpg. And how would you like to rename this object so that it wouldn't collide with yours? So we'll construct a new path. This one has new in it. And we call our own insert. And then we're done. And now, hopefully, after this is done, we can go back to the mesh. We can reload. And in a moment now, we will see that we now have 2 files. One is lake, and the other is lake new, even though we were this logic was actually taking place on the local machine. All right, so the idea is that while the sync framework has to do a lot of work in order to support these constraint conflicts, the work that the provider has to do in order to implement constraint conflict support is actually quite small. The last topic I wanted to talk about today is conflict logging. Again, this is something that is supported by V1. You may recall that a provider can return a transfer and defer option as a conflict resolution action, and in this way indicate conflict logging. But providers in V1 have to do a fair amount of work in order to actually support this. In V2, we're simplifying these things dramatically. What we're basically saying, what we're basically leaving to providers is the need to implement an interface called iConflict log access, which does for providers effectively what provider framework does for full enumeration providers. The only thing provider needs to do is be able to write conflict records, delete conflict records, and enumerate conflict records. Sync framework takes care of making sure that the right conflicts are sent to the right replicas, making sure that conflicts are not sent again to the same replica that has already received them, no matter which path it received them on. And most importantly, cleaning up the conflicts after they've been resolved. If you have a community of 10 replicas and a conflict occurs, any one of those 10 replicas can resolve the conflict, and every one of those 10 replicas will see the resolution and will see the conflict disappear. All of this will happen automatically, and the provider just needs to implement iConflict log access interface. All right, and with that, so what I talked about were a couple of things about the sync framework, V2, and how it's differentiated from V1. One is support for a number of new endpoints that the sync framework is really the easiest way to synchronize your data store with. Among those is LiveMesh, ADO.NET data services, SQL data services, and a lot more. The second thing is the provider framework, which makes it really easy to write providers for certain classes of stores. And finally, there's a number of advanced features. Only a few of these I had time to talk about in the area of filtering, conflict logging, and constraint conflicts. And with that, there's a number of resources that we have that are available for more information. There is our development center in MSDN, we have a blog. We have SQL Labs that I wanted to plug, which is where all our new functionality and particularly some of the newer prototypes, such as Project Anchorage, will be made available first. And finally, we have a number of sessions, such as a session on the BB40 session on synchronizing to SQL data services, another on synchronizing to ADO.NET data services, synchronizing with Windows 7, and finally, synchronization inside LiveMesh. And of course, you're most welcome to visit us at the booth and ask the experts section. This session is recorded, and please fill out session evaluation. It's really important for us to know what you thought. And questions? If you can please use the microphones, it'll help record the questions, but either way.
First of all, I would like to thank you for giving a nice overview of Sync Framework. I have two questions really. First one is...
Is Mike? Can we?
Yeah, it's
okay.
The first question is two networks, right? How do the Sync Framework, like assume, I'm going to give a scenario here. This side of the world is working on a hub environment where synchronization has been happened. Now I disconnect from here, I come to a real network.
Mm-hmm.
What does happen? When do the delta get synchronized to the other endpoint?
So so synchronization framework doesn't schedule synchronization. What happens is when you connect the computer to the other network, you will initiate sync at some point, whether it's scheduled.
So the user has to initiate it.
So the sync application has to initiate it, right?
Okay.
So many sync applications like Anchorage, for instance, I didn't click that button, but many sync applications like Anchorage supports scheduling synchronizations and or running synchronization on events like network connects or network disconnects. That is not strictly a feature of sync framework, it is a feature of sync applications.
Okay, very good. Okay, the second question what I have is, Microsoft GRU essentially does the same thing.
Sorry, what again?
Microsoft GRU
yes.
essentially does the same
Yes.
concepts. How different is the GRU or
Yes.
the Sync framework from the GRU?
Very good. So Groove is a product. Right?
Correct.
Groove is a product. It's a higher level experience on top of this kind of synchronization technology. Sync framework is something that allows you to synchronize your own stores using the same principles, the same net changes principles as Groove synchronization and the new releases. So Groove is a higher level product on top of the same infrastructure.
So does that mean that the sync framework is built based on like a Groove Dynamics engine?
No, it is not.
It's not. It's two different product family.
Correct. That is correct.
Okay. Thank you so much.
Sure.
I have two questions actually. The first one is related to the scalability. Is the amount of data that need to be synchronized increase and the amount of nodes that need to be synchronized? Do you have any statistics? Give us a gut feel about the scalability.
Sure.
Okay, and then I'll go with the second question.
Okay. So the scalability comes in several areas. I don't want to, rather than giving numbers, I want to explain where the scalability problems come from. So one of them is the amount of metadata that Sync Framework maintains. Sync Framework maintains very little. It maintains per object. As the number of objects that you have grows, the amount of metadata grows linearly in that we only keep a single version or two versions per object. Okay? As the number of replicas in your community grows, the amount of per item metadata doesn't grow at all. The only thing that grows is the amount of per scope metadata.
So only the metadata is compared and versioned.
Yes, correct. So as far as the actual performance of Sync Framework, when you have a lot of data to synchronize, frankly, that depends mostly on how good your provider is. So for instance, we have a SQL Server provider, we have a relational provider, right, that is built on Sync Framework and is used to synchronize huge quantities of data in SQL Server with other SQL servers or with
So the SQL provider take care of the deltas.
So that is correct. If your provider, for instance, is an anchor-based provider, true anchor-based provider, your performance is going to be good. If your provider is, full enumeration, yeah, not so much.
Thanks. And the second question, I apologize to the other colleagues. The focus here was mainly about data, bits from one node to another. Well, how about if I want to synchronize something that's not only data-driven, but there is certain operations, certain code that have to be run along with this. And I'll give you a simple example. Let's say I have a code modules, and I want to synchronize the code modules from a bunch of machines to have the same code modules. Well, if it's a COM component, it needs to be registered. Mm-hmm. So the trick is not only to synchronize the binaries, the data, but also the post-sync command that I have to run in order to make the sync complete.
Perfect.
So is there any scenario?
Yeah. Realize this is one of the reasons why we believe that it's so important to keep the provider model open. We are not about synchronizing two data stores. We're not about saying you have this file and we're going to sync it for you. We're about synchronizing providers written against applications. So if your problem domain is that of synchronizing COM components, then in your provider, what you're going to do is when you're implementing that insert method, you're going to register the COM component as it comes in. We'll take care of the sync bits. You take care of the business logic. That's how we train to.
Thank you.
Sure.
Hello. The question that I have is like a scenario where you want to actually do, we're using Groove for quite some time now. So we want to try this, like we're going to add an application that works on SQL, not on Groove, to avoid the limitation that we face with Groove. And basically synchronize the data from the local SQL with Groove engine so that Groove can actually synchronize data on a peer using Groove's dynamics.
Yep.
And then when the data reaches on the other peer, the data again gets synchronized with Groove's data with the local SQL.
Yes.
So that's a scenario that we probably are thinking on doing. Is that a scenario that could be supported using this?
Absolutely, absolutely. I mean, at the moment you'd have to write a Groove provider,
right?
Because one is not available.
Right.
But other than that, yeah, absolutely. This is a perfect scenario.
Okay. So probably if there's a Groove provider available, then probably it's the existing Groove clients might well go on local SQL and then might still take the advantage of Groove synchronization.
It could. I mean, that's not how it put together quite at the moment.
Thanks.
Sure.
My company's been trying to, explore Sync Framework as a means to synchronize all of our data because we have thousands of clients, and they all have to go through like a service, like a whole set of servers, and it ultimately goes into our data warehouse. now I'm looking at all the examples. All the examples are like from one server sync to a client. But if in our scenarios, we've got thousands of them, so we don't necessarily want to have all go to one server. We want to be able to switch, add new ones, and if one dies, it doesn't affect our operation. For our scenario, then, do we need to rewrite all of our providers? How does that?
Oh, definitely not. No. So that's actually that's a wonderful question. So, Sync Framework is specifically set up, despite possibly what I drew on the slides. Sync Framework is specifically set up to support multi-master synchronization. Okay, so you do not have to synchronize everything through one hub. You can synchronize things in any topology that you choose. Of course, you could do things peer-to-peer, but with thousands of clients, that's probably not what you're looking to do. But what you can do is you can, for instance, let's say you decide that for scalability reasons, the right thing to do is to have 10 servers. Okay? So you have your 10 servers, and you send your clients to synchronize with any one of these servers according to your own logic. The servers then resynchronize amongst themselves. That will work perfectly well with Sync Framework.
Okay.
That's sort of the point of the multi-master support, is to basically say you don't have to have a single hub.
So you're saying that if, let's say, I use SQL Server 2008 on those 10 servers, and the clients are using like Microsoft, I forgot.
SQL C?
Yes.
Uh-huh.
So in that scenario, I don't even need to write my own providers because you.
That is true as of Sync Framework v2. That is correct.
Oh, okay. But in V1, if I want to use V1, then I do need to.
The relational provider in V1 does not support this scenario. The relational provider in V2 does.
Oh, okay. Right. Thank you.
Okay.
A lot of your example used the last modified date. Is there a way to also maybe do a synchronization and comparison based on versions, based on lineage, or based on binary compare between files?
Yeah. So there's one thing. So absolutely, I use last modified time. That was just an example. The provider in general decides how it wants to determine whether an object has changed. So you can definitely do it on the basis of binary comparison. I would do it on the basis of a hash of a binary comparison. On the binary hash is probably more efficient. Or you can do it on the basis of version, I think you said, yeah?
Yeah.
I wanted to address the lineage. The lineage would be an overkill because lineage is typically used in order to make sure that your solution can support conflicts and can properly detect conflicts. Mm-hmm. That is something that we will already do for you. The only thing you need to be able to tell is if an object has changed, it's true or false. And then we'll take care of the rest of it. But okay. You could do it on the basis of that as well. Last modified time was just an example.
Okay. And we have a concept of master and replicas.
Okay.
And so does the MSF take care of synchronization between replicas where, it's more like a read-only copies? Because if you have some sort of conflicts at that point, how do you resolve it? Is that part of the business logic layer, or is that taken care of by?
So let me make sure I understand. So in your scenario, you have a hub, and then you have your replicas as read-only, and you're trying to enable the replicas to synchronize directly without the hub.
Correct.
Yeah, you definitely can do that. So Sync Framework definitely supports that. If you're going to detect a conflict at that time, you have options. One is to resolve this conflict and to basically say, hey, my replicas are logically read-only. But physically, yeah, sometimes they push up changes anyway. I don't let users make changes on my replica. But if it happens to acquire some through synchronization, it can push it up. That's one approach. The other approach is to say, is to use that. In all my conflict examples, I always had one option for do not resolve the conflict, right? So what you can say is you can say, if I detect a conflict peer-to-peer, I will just refuse to resolve it. The server will take care of it eventually. Meanwhile, I'm just going to not sync this object. And that's okay too, depending on your scenario.
Okay.
Works for us.
Thank you.
Sure.
Hi. I think you've answered some of the question, but the question is about system of record. So if I've got multiple systems of record, how does this work with that? So I've got customer data in a JD Edwards application, orders in Siebel, for example. How does this fit in with that concept? Or is that more of a SQL master system of record?
So, you can definitely sync all of your replicas with your system of record, and you can choose to, if you have multiple systems of record for different types of data, I presume, then you can sync replicas. You can define scopes for the different types of data for which you have different systems of record. If you have multiple systems of record for the same piece of data, I'm not quite sure what that means.
So what I'm saying is, say you've got your customer's data in JDatabase, but potentially you don't want to replicate that in another database store.
Okay.
But you still want to have that view with maybe a replica in that other database store, or just a view of both stores. Is there a way of applying rules and other things to sort of turn it off for other stores and leave it on for?
Well, you can definitely control which piece of data flows to which replica. So if a particular part of your data you don't want to replicate to a particular replica, that is easily done in one of two ways. You can either just define different scopes, or you can use the filtering logic of V2 that I was talking about. So that's easy to support. If your sets of data are fixed, then you can just define different sync scopes, and then have some of them sync to some machines and others not.
Okay. Just one last question.
Right.
The Astoria story, at the moment it's a bit kind of all over the place, because at the moment you don't support Astoria. I know there's a session on that.
Exactly. I would very much encourage yeah. So yeah, we're working very closely with the Astoria team to enable Astoria offline. Pablo has some wonderful demos of how it works, and we'll have prototypes available. So this is you're right to say that we haven't released anything in the space, but it is a very
Well, that's part
very
of
much
V2 is going to align both.
It's very much, yes, it's very much hot topic that's being worked on.
Okay, great. Thanks.
I have a question. What if I have integration beside synchronization center? If I have 3 stores that have different representation of an item, different ways to model the same thing. For example, one could have a customer as one record, and the other would have individual and customer as a role, or something like that. So you would have 2 records in other stores. How do you solve that kind of?
Very cool, very cool. So there's a simple part and a hard part. So well, okay, they're both hard, I guess. So first part is being able to convert from one representation to the other. Okay, it's not something we can solve for you. It is something that you have to write. You have to write a bidirectional converter. You have to be able to convert from this to this and from this to that. If you have written that code, it is trivial to hook up 2 providers and a converter, and to basically say, okay, well, I have one provider which expects this data format, another provider which expects that data format, converter that converts between them, go. Okay, that is very easy to do particularly if your converter is lossless. If, however, your converter loses data, right, maybe one of your representations is richer than the other, then you need to use filtered synchronization, that column level filtering that I was talking about.
And what about when the item count is not the same? For example, if I have a record for individual and record for customer role, and on the other side I have only customer.
That is quite a bit harder. That is quite a bit harder. You need to. We assume that the notion of an object in one provider matches the notion of an object in the other provider. So you need to write a provider that will agree on that and expose one of these. So typically you would take the larger object, agree on that as the object, and then have the guy who's representing the customer as a bunch of rows aggregate those rows into a single customer and report that. You can use with Astoria, going to the previous question, if you are using relational stores, for instance, you can use EDM and Astoria to define these higher level objects. Okay? And if you can get the EDM models of your objects to line up, then even though their relational structures are different, you'll be able to sync them without having to do much work. But
so for example, if I have 3 different applications, I would take the one that supports least amount of concepts and align every other to that.
You certainly could if you don't need if the other applications are okay with that. It only gets harder if you need to sync smarter applications through a dumber application. That's where things get more complicated.
Thank you.
Okay.
2 small questions. We're about to do a system which is going to use SQL replication. Would we consider this instead of replication, or does it not fit?
When you say SQL replication, are you referring to transactional replication or merge?
Transaction.
Typically, no.
No.
Right? Typically, transactional replication has typically operates in environments where several things are needed and several things are not needed. So, for one, it guarantees transactional consistency of the database at any given time. We do not, by design. Right? By design, Sync Framework says we guarantee consistency of an object, but we do not guarantee consistency across objects, because if we did, we wouldn't be able to resolve conflicts. So a transactional replication is typically not used in situations where there are many conflicts, right? They're typically used in situations where you have a master-slave relationship and you're propagating changes, for instance. That's the typical use, yeah? In which case, conflicts do not occur. So, yeah, typically you wouldn't be considering sync framework in a case where you're using transactional replication.
Okay.
But talk about the details.
Yeah, the other one was the protocols and stuff that are used. Can they be interchanged? Can you sync by bits or something else?
Absolutely. So we do not define. So sync framework technically is protocol independent.
Okay.
Right? There are some protocols that have been defined that like FeedSync, for instance, which is a really good protocol for sync framework, so you can use that. But in general, most of our solutions, I mean, all the solutions that exist today use custom protocols. So they basically say, oh, the way I'm going to encode changes is like this, and they send them around, and we're perfectly happy because as far as we're concerned, a protocol is just another provider, and we don't really care what's on the other side of it.
So we get to write our own, basically.
But you do get to write your own. There are no protocols. The only thing that we intend to support, and yeah, so I should just say, yeah, there's no, we don't have any protocols that are supported out of the box by Sync Framework other than FeedSync.
Right. Okay, thank you.
Okay.
I got a question for you. My company, we've written a prototype that syncs the files on the client to the server using an algorithm called rsync. Now, why would I want to use something like Sync Framework to... can I use rsync with the Sync Framework? Or RDC kind of algorithm?
Yeah, you can definitely use RDC with Sync Framework. Absolutely. So there are... So let me answer the first half of your question first. So in general, I don't want to, if you're happy with your sync solution, right, there's no need to switch away from it in general. So if you're happy with what you have, then that's wonderful. The reason to use Sync Framework is twofold. Your desire to interoperate with other solutions, and that you're missing something, right, in your solution that you'd like to add. Okay. The second part of the question on RDC, yes, absolutely. RDC and other technologies like this plug into the data transfer interface of the Sync Framework. If you look at in V1, I didn't talk about this because this hasn't changed between V1 and V2, but there is a point of, there's a plug-in point in Sync Framework where a data transfer interface comes in, and in that, it is there that you would plug in RDC. So we've done that as a prototype, for instance, but we haven't released that yet.
Okay, so that doesn't go into the provider.
It does go in the
RDC.
It does go in the provider. It is one of the. So transfer interface is one part that providers agree upon. It has to go into both providers, right? Because if you want to use RDC, then both sides have to use RDC. Otherwise, it doesn't work.
Yeah, because it's like a three-way handshake, almost pretty much. Right? You're sending a hash.
You don't have to make it a three-way. You can maintain the modality of synchronization session without and still use techniques like RDC. rsync is a three-way handshake.
Okay.
But
all right. Okay. Great. Thanks.
Okay.
Just a quick question. Are there plans to provide the plumbing so that you can build an application that can do real-time synchronization or close to it?
So, good. And by that you mean as changes happen, they're replicated to the other side?
Basically a provider to emit an event that says something changed and, you know.
Yeah. So there are two ways in which you can do this today. One is to run notification-based sync, okay? Where whenever you detect a change, I mean, we can't detect a change, but whenever your provider detects a change in the store, it says, now would be a perfect time to sync, okay? Lots of stores do that. I mean, they could right-click and encourage, you know. So this is easy to set up. This doesn't give you quite real time, because there's still a gap between you detect a change, and then we'll go to enumerate the change, and we'll send the changes over, right? It still feels batched. If you really want to build a solution which notices a change and sends a change, you can do that by using a lower level. Basically, you would have to use the sync runtime of the sync framework without using the orchestrator. What you would do is, whenever you detect a change, you would package that change using our metadata, send it to the other side, and we would apply it on the other side. Okay? We have customers who do that. It's very doable, but yeah, it certainly is more effort, because you get to you benefit from fewer of our layers. You only benefit from our lower layers.
Thanks.
All right.
In terms of the provider framework, if you write like an anchorage data sync provider, does that mean that you basically, if you have a smart sync provider that actually can tell you what has been changed since yesterday or the day before, then basically the metadata that the framework has to maintain would be less?
That is absolutely true. That is
so
absolutely
that basically, if you have a smart provider, then you technically basically don't need that framework as much.
Absolutely, absolutely.
So giving that, yeah.
Sorry, just to quickly say, there are 3 levels. You can say, even if you go from full enumeration provider to anchor-based provider, we already have to do less. And if you go from that to a provider that just takes care of implementing sync provider interfaces, we have to do even less. So,
So does that mean that, so I'm not sure what do you guys maintain in that metadata? Is that you maintain IDs of insert, update, delete, or the time of the changes, and then basically...
In which case?
Let's just say the simple provider, the simple sync provider.
For the simple sync provider, we maintain several things. So first of all, we maintain the normal sync framework metadata. So we maintain creation version, update versions, IDs. Okay. No.
So you mentioned the whole role, or just...
No. We never store any data.
Just made it.
Just the. So, I'm sorry. When I say version, it's a term from Sync Framework V1. It just two integers. So it's not. There's no data involved. So that's what we maintain. In addition to that, we maintain. In addition to that, if you have a full enumeration provider, we store those properties that I mentioned that identify your object and identify its version. We store that in our metadata store. If you're going to write your own anchor-based provider, we don't store those anymore. Right? And if you're going to write your own provider altogether, then we don't even have to store the sync framework metadata. You get to store it yourself in whatever store you choose. So, for instance, certainly a SQL provider stores the metadata in its own SQL. I mean, in the SQL database, and doesn't rely on the sync framework to store it for it.
Yeah, last one, which is very quick. The optimistic concurrency, where you can actually ship regional rows from like one provider to the other side, because maybe the other side wouldn't be able to detect conflict without knowing what the original value was. So is that supported somehow? Where and how?
So the important part is you mentioned detection of conflicts.
Yeah.
Okay. So all our providers.
Yeah.
Even if they're a full enumeration provider, the simplest kind, will correctly detect conflicts at all times. Okay? This is the metadata. This is the beauty of Sync Framework itself. We maintain enough metadata without having to keep previous versions.
Yeah.
We maintain enough metadata with our knowledge and our versions to always be able to detect whether a conflict has occurred. Okay? Now, that being said, some providers like having previous versions to resolve conflicts, to do like 3-way merges and things like that. You can do that with Sync Framework. We don't mandate that by instruction. But I wanted to make sure it's clear. Conflict detection is something we take care of.
Even though you don't know what the original value is?
We don't need to know what the original value is because we have the knowledge and the versions. It's a fancy thing. I'm happy to describe it in detail, but it needs a whiteboard. All right.